topic. I've been given to understand that the previous speaker has already introduced climate change quite at length. So looking at the topic of the talk, I had kind of put in some context slides. So I'm going to kind of do a fast forward on those things. I'm not going to spend too much time on this, but just to kind of set the context, the reason that we are worried about climate change as an issue, as rightly pointed out, is that never in the history of Earth did we cross the dotted line that you see on this particular graph, right? So this is in comparison to the 1950 average, and what you see, I would want you to pay attention to is the scale up there, 800,000 years. That's a very long time scale that we are talking about, and never in the history of Earth had ever that particular, the graph that you see there, has it crossed that particular line. And what you see is that it's only in the near past that this tipping has actually happened. Now, as you can see from this graph, it's been increasing, it's been decreasing, so it seems like, okay, maybe it was a natural process of increase and decline. The crests and troughs kind of interchange, they go in a cyclic manner. But the problem is the rate at which it has happened in such a small time scale, and it's just overshot everything that happened in 800,000 years. So, which is why the entire world, be it the politicians around the world, be it the scientists around the world, be it the policymakers around the world, everybody is concerned about it. And if you know the history of climate and climate convention, it was in Rio de Janeiro that the entire thing came into focus, and everybody started talking about climate change as an issue, and as a science, it's evolved over time. So moving forward, another context that's important for us to remember whenever we are looking at solution to the problem is that it very clearly, this particular graph very clearly illustrates that we humans have had a hand in the problem becoming much more than what it was in the past. It's escalated over time. So which is why what you see in this particular graph is the natural causes. If it was where the natural causes, we would have been where this particular graph is showing. But then it's only the combined effect of natural and the human influence is what has made us to be where we are today. So which is why when you're looking at the solution to the problem, you really need to understand the problem in its entirety. So the clear signals, as you must have heard the previous speakers also speak about, is there's been temperature changes, large scale warming largely all across the world. Every decade every year there are new records being made with respect to the highest temperatures being recorded. And of course even the precipitation changes, sea level rise, and so on and so forth. There are enough signals that you cannot ignore anymore and say that, okay, it's a natural process that's happening and we don't need to do anything about it. So the very, very stark signals that are emerging. So just to kind of sum up some of the big things that are happening as it's been put together by the Intergovernmental Panel on Climate Change. The carbon dioxide concentration that's being recorded now is highest in at least 2 million years, fastest rate of sea level rise in about 3,000 years, lowest level extent of Arctic ice in 1,000 years, and unprecedented glacial retreat. These are first order impacts that we are talking about, the signals. But then the second and third order, which is to do with rainfall patterns changing, heat waves, as a result of heat waves, the related productivity issues, labor and other things. And also when you're talking about extreme rainfall events, the kind of flooding that happens, its impact on multiple things is something that those are the second and third order impacts. So given that there are multiple impacts, that's global, but even when you look at India, there has been quite some significant change. Some work that we did at our center, we see that the summer maximum temperature, which is your March, April, May temperatures, right? So if you look at even the 30-year period, just before 2020 or 2022, there's been quite some substantial increase in the summer maximum temperature. The same goes to say even with the winter minimum temperature. Even if you look at the rainfall, the Kharif season or the June, July, August, September, the primary monsoon season, there's been an increase in rainfall, right? The patterns are changing. When I say increase, it seems like good news if you're talking about the drier regions, but it's not always good news because it doesn't get distributed evenly. You have heavy rainfall events, you will have an extended dry spell or a drought, and then there is another bucket of rainfall that happens. So which is why the variability is the biggest concern, and that's why this becomes a larger issue any part of the globe that you look at. Now the biggest factors that are contributing to the problem of climate change, before we get into the mitigation aspect, is we need to look at which are the sectors, which are the culprits basically. So wherever you look at, we all know that the power sector is definitely, if it's coal power, there are emissions related to that, basically fossil fuel use in general. So transport sector again is one of the key emitters. You look at industry, industrial processes are heat intensive processes, they consume a lot of energy, and they emit a lot of greenhouse gases as well. Now although we say carbon dioxide, essentially that's not the only gas that's of concern. There is methane, there is nitrous oxide, there are hexafluorides, HF6, SF6 and a whole bunch of other greenhouse gases. But we convert it to CO2 terms and generally say, okay, in CO2 equivalent terms, the increase is quite large, right? And as you see in this picture, even agriculture, because if you obviously, rice cultivation, as you will all know, is a very water intensive cultivation that happens. And when you have standing water for extended periods of time, there's anaerobic conditions that are created that results in methane emissions. So that's also a sector that is contributing to the greenhouse gas emissions. Livestock, I will not get into the details, but that's also a sector. When we actually talk about the carbon budgets and the kind of emissions that happen across the globe or even within India, there's something called a national communications that Government of India prepares. There you look at every single sector and how much is each of these sectors emitting. Now there is one sector which is not an emitter by and large, at least within India, which is the forest. So when you grow forest, simple school science, photosynthesis, CO2 gets captured, right? So that's why the forests are called the sink of carbon as opposed to all other sectors that we talk about. Now because of this, we are seeing large scale impacts. It touches every single stream of life that we are depending on or we are very closely related to, be it agriculture, be it health for that matter, forests and biodiversity. In the next session, you'll be actually listening into Dr. Mahesh Shankar, who will be talking about grasslands, which is a very crucial ecosystem in itself. You will understand the importance of these ecosystems as you listen to him. So other than that, even the food produce, the coffee that we drink, the tea, the cocoa production, there have been studies across the world where they found that changes in temperature, changes in the soil moisture conditions because of changes in rainfall can actually impact the flavors of these produce. So the coffee that you drink today may not taste the same if climate change continues. There have been studies across the world which are trying to kind of demonstrate that. So that there are enough and more than enough evidence to show that the impacts are quite large. And the biggest problem is that climate change is actually a threat or a risk multiplier. Now it's just one component that we are talking about, but the thing is, it can impact all sectors, all streams of the economy, it touches lives and livelihoods. So obviously, where there are disparities, where there are already issues, it will aggravate the issues to be much larger, which is why it definitely is a case for action. It's real, it's happening, and it's today and it's now. It's not far away in the future. So we really need to start acting. And projections, climate projections, there are models which kind of say how will the temperature change, how will the rainfall patterns change, how will the extreme events be moving into the future, say 30 years down the lane, 50 years or 100 years. And very clearly what we see is, by and large, it's a warmer and a wetter future, right? So obviously, which means you are also looking at extreme events like heat waves, heavy rainfall events, more droughts, more frequent, more higher magnitude levels. And that's something we are already experiencing. We read every day in the newspaper about some extreme event or the other in different parts of the world. So, which is definitely an important case, particularly in a developing country like India, because we are dependent, we have a lot of what we call as the climate sensitive sectors. Agriculture, as you know, is a very climate sensitive sector. Take for example Karnataka itself. I've been given to believe that most of you here are based out of Karnataka or are from Karnataka. Rainfed agriculture in Karnataka is almost 70%. There is no assured irrigation, so there is no timely rainfall, there is no even distribution of rainfall. Then obviously that is a problem to agriculture, that's a problem to food production. So when yield gets compromised, then you have markets, economy, people's lives, livelihoods, a whole bunch of other things that kind of begin to emanate from that singular problem. So all of these underpin the need for climate action. Now when we say climate action, it's a two-pronged approach. One is what we call as mitigation, the other is what is called as adaptation. Now without getting into what or how it is defined in general, I'll just spend a minute trying to explain to you in very simple terms how each of these are different, right? When you talk about adaptation, we are trying to actually look at solution from the impact side. You have impact, so you're trying to see how do you reduce the impact, right, over a period of time. That's all about adaptation. It's due to existing. It's basically there have been greenhouse gas emissions that have happened over many decades, centuries, and the impacts are being felt today. Now the problem is these are varied across different geographies. What happens in Jammu and Kashmir may not be the same as what happens in northern Karnataka. So it's very local and it's extremely context specific. The kind of solutions that you look for here is extremely local and context specific. And then of course it's basically you're trying to look at how do I protect, how do I decrease, how do I buffer any harm that's occurring because of whatever has happened in the past because of emissions. Whereas when you say mitigation, the general English term mitigation is to avert, yes, but when you talk of it from a climate perspective, we are talking about how do we prevent future emissions, future carbon emissions. That's what we are talking about. Now we talked about all those various different sectors. So in each of those sectors, what is it that can be done which will reduce the amount of greenhouse gases that are emitted into the atmosphere. So it's long term. It's looking forward. It's a forward-thinking approach that goes in. And it also tries to look at how do you reduce the severity of any future climate harm. So that's what mitigation is all about. You try to kind of look at those aspects. So this is what is very important to understand. Mitigation has to happen. Now it is never this or that in the climate action space. You need to do mitigation, but at the same time you also need to do adaptation. Now the reason why we need to adapt is because mitigation is a long-term solution. It's slow, it requires global action. It's not necessary that okay in Karnataka or let's say in India, if we do all actions which do not worsen the problem of climate change, it's not going to solve the problem. It's a global problem. Every country around the world needs to act on certain things, which is why there are these what is called as a climate negotiation that happens year after year in November, December. It's called the COP. You will start reading about it very soon in the newspapers. The Conference of Parties. It's the 28th Conference of Parties that's going to happen very soon, where climate leaders around the world or leaders from different parts of the world, the presidents and prime ministers of every important country, about 190 plus countries all gather to actually talk about what is that action, because it's a concerted effort. They need to agree on things and it cannot be imposed. They need to be able to do certain things, but remember that requires finance, which is where all that negotiation leads into. Now let's look at what are the big tickets when we are talking about mitigation. I'm kind of doing this very fast because we started almost 35 minutes late. So I will keep it quite short, but I'm open to question and answer, which we can spend like 15-20 minutes if you want some elaboration further on. So looking at what are the solutions and approaches that are being practiced, that are being implemented across various parts of the world, including India. As I said, power sector is one of the key things. And I'm sure all of you know that India is going big on renewable energy, right? So we see a lot of electric vehicles coming on the roads these days. There are solar parks being built, wind power plants, wind plants that are actually being implemented. Now, that is a way to decrease our dependency on coal power. But there are issues there, primarily because, again, if you look at the renewables, that's also a climate sensitive sector, because the sun doesn't shine all year through in all parts of India, right? And the wind is also not the best. I mean, you can't produce wind energy in every part of India. Now, which means you need storage. Now, technology for storage is again something that's still emerging. There's a lot of research that's going on, but there's a lot that needs to be done. Now, the electric cars that you see, that there is a problem with the range, right? I'm sure you hear about the range and other things, because people want to invest, but they say, I can't travel beyond so many kilometers. I need infrastructure for charging my electric vehicle. So people kind of shy away from that. So there is infrastructure development that needs to happen, which is related to EV becoming larger. Now again, if the electric vehicle is an electric vehicle or it's a clean energy, only if your source of charging is from a renewable power. Now again, if you are plugging into a socket which is coming from a coal power plant, we're not doing anything great. You're actually creating another loop there, because your batteries, you have to recycle them. Do we have recycling technologies, or are we going to create more waste? So these are difficult questions, but then every country, every group is trying to look at, try to find answers around these. Now similarly, when you look at electric mobility, I already spoke about. Now talking about deforestation, maybe in India it's not really such a large problem, but at the same time, in many parts of the world, in countries like Indonesia, Brazil and other places, deforestation is one of the biggest problems, because when you cut a forest, as I told you, they are sinks of carbon. Now if the wood is burnt, all the carbon that is stored in the wood gets released. But if it's converted into, say, a table or a chair, now these particular products have a life, right? It could be there for 100 years. If some of you have ancestral homes of 100 years or 150 years, traditionally homes were built with wood only. You will have very old doors, 150 years old doors. Now, you don't replace it, right? It's good enough even today. So, as long as the produce is in use, you don't burn it, the carbon is stored, some amount of carbon is stored. But the minute you burn it, it gets released. Now, the other problem is that whenever we talk about forest, the sink of carbon is not just the tree, it's also the soil underneath the standing live forest. Now when you cut down the forest, you're basically exposing that soil to direct sunlight if you don't convert it to anything else. So there is oxidation, there is release of large amounts of carbon that can happen. Which is why when you talk about forest, we consider it as a forest carbon sink, and when there is deforestation, it becomes a source. Right? So that's the way it is looked at. Now, you will see something very interesting, and you might be wondering, how does reducing meat consumption has anything to do with emissions? But it's kind of, red meat is it has a very large footprint. It's not about just eating, it's about the entire life cycle of that particular produce, right? From production to it being transported, it's being stored, cold storage that goes with it. So every single thing, cradle to grave, if you look at where it is produced to where it is consumed, if you look at the footprint of a vegetarian diet, like proteins and pulses, have a very smaller footprint as compared to meat. So that's been very clearly established. So that's dietary shifts is definitely one of the key things that's important when you look at solving the problem of climate change. Likewise, carbon capture and storage technologies. Now, this is one case where it becomes very, very important in the mitigation space when you are looking at certain sectors or certain kinds of industries. Anybody from engineering background here? Okay. students maybe. Not a problem. So, but if you look at the iron and steel industry, when you look at cement industry, there are huge emissions coming from these. Now, the technologies are already quite mature in these industries, and they're very heat intensive processes that go in there. Now, to switch to anything beyond what exists today, A, technology is limited, B, probably it's very hard to get the emissions to zero. So in which case you need to adopt what is called as carbon capture and storage. Now people are also talking about carbon capture, storage and utilization. How do you utilize the captured carbon? Can you put it back into other processes? So these are questions. There is very limited work that's being done on this, but it's a very important space because there are certain sectors where you can never hit ground zero, come whatever you do, it's impossible to get it to ground.